So we'll start over again with that. Hi, welcome to the second episode of Unhindered by Coding, the tentative name for this stream, live programming stream. This is episode 2. Episode 1 was last Tuesday. The video resolution wasn't super awesome. I didn't think last time, so I'm trying to up that this time. We'll see how that goes. Definitely let me know if there are issues on your end. We'll be here for 2 hours today. Continuing with the rustling exercises. We started that on Tuesday. Made it through about a third of the exercises. So I don't expect we'll finish today because if anything, the exercises are getting more complicated. But yeah, we'll work on that. I'm Nick McPhee. With that handle on most things except for Instagram. But such is life. I do want to mention that I will be... Come on. There we go. I will be at Minnebar next week. Make that a little bigger. So this has two implications. One, I just want to tell you, in case you're in the Minnesota area and want to attend Minnebar or are planning to attend Minnebar, I will be there giving a presentation, Silico Paleontology, using graph databases to analyze evolved programs. I might use Tuesday's stream to try to follow, to do some work related to this. So we might take a break from the Rust thing. I'll make that decision when I'm closer to the day. I'm considering using the NeoVis JavaScript library to try to do some interactive web view on a graph database as part of this talk. We'll see if that's what actually happens. But Minnebar is awesome. Whether you come to my talk or not, Minnebar is an amazing thing. Free to attend. Lots of food, lots of great talks. I think it's a really wonderful event. I have missed it the last few years because of COVID, and I'm really looking forward to returning to it. So I figured I'd let you know that. So any questions about anything before we actually get started on the Rust stuff? Not seeing any. Let us go back to Rust. Okay, so you may remember Rustlings. Actually, I can. So Rustlings is a set of exercises provided by the Rust community as a way to learn some key aspects of Rust in an interactive setting. It's a very nice deal. And like I said, I started this last week and got through about a third of the exercises. So we'll pick up where we left off. And that'll be hopefully super fun. So this is, I've got the same project up in VS Code. We can say Rustlings. Actually, one of the things we can do is Rustlings, I forget, help? Is that going to give us? Verify, that's what I wanted. Rustlings, verify. So this will actually go through and check what you've completed and what you haven't completed. And so this shows the ones we did last time. And we then fail on Struct 2, which is exactly where we'd expect. So we can see we did quite a few here, and we'll pick up on Struct 2 now. Okay, so it says address all the to-dos to make the test pass. And there is a to-do. Okay. So we've defined a struct order, which has a bunch of information about an order, who placed the order, etc. And we have a function that creates an order template that returns an instance of order with filled in values for the various fields. So the order's from Bob, it was made in 2019, blah, 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 blah. And so our job is to create our own order using the update syntax and the template above. And I think our job here is just to, well, actually, I'm not sure. I'm not sure what the update syntax means. Oh, actually, let's, grab a terminal, pull that in, make you a more reasonable size, increase the font size a little, and if we grab the hinty thing, oh, they don't have a hinty thing. Okay, I'm gonna actually search for the update syntax. So I'm gonna make sure Rust struct update syntax. I'm not 100% sure I know what that means. Defining and instantiating structs. So this is what the template does. And oh, here we go. Creating instances from other instance with struct update syntax. So if we have user 2, so we can use ... user 1 to get everything from user 1 that we're not overwriting. So we can specify new fields where that makes sense, and then just grab the other fields from an existing template. So I think back here, name, year, made by phone. Is this all the same things? Let's say it is. I don't know quite what the value of that's going to be then, but yeah, we'll try it. Order. And so it was just field : value. So name : hacker in Rust, year : everything else is from the order template. So we don't need to include those. We'll do the ... thing. We'll have to set the count to be 1. Cannot spell. And then comma ... other thing. Comma ... order template. So in theory, we have specified all the fields by using the template for these, and we have then sort of overridden the template here and here. So in theory, that should pass. Oh, and we should be doing Rustlings watch here. So it's going to oh, I could have just done this. Well, we'll wait for it to grind through everything. And it did not like it. Oh, I can't do syntax. I need a semicolon there. Oh, and it doesn't like hacker in Rust here. So we need a string from. String from. I think this is one of the aspects of Rust that I'm just so used to being able to like write strings and have them be strings. And the whole string slice string thing continues to cause me stress, but we're getting better at it. Okay, so that worked. And I don't think I have anything else that I want to explore here. I think that's really cool that you can take a struct and make a new struct based on it and override just the pieces that you need. I suspect that's useful. Off the top of my head, I think that it probably doesn't feel useful to me right away, in part because I'm used to things where everything's mutable. And so you would just take a struct and smash it. Whereas here, since a lot of things are not going to be mutable by default, you don't make a new struct. You don't change an existing struct. You make a new struct and update some of its components. That's a guess. But it seems like that would be one of the places where that would be useful. Okay, so we're going to get rid of this. Pew, pew. And this will move us on to struct 3. Okay, so what's going on here? Structs contain data, but can also have logic. In this exercise, we have defined a package struct, and we want to test some logic attached to it. Make the code compile and the test pass. And they do give us a hint here. So we have a package, which has a sender and a recipient country and a weight. Interesting that they used an I-32 here. I would have thought like a U-32 would have made more sense, because I don't see how you could have negative grams, but yeah. And now we've implemented on package a couple of methods. So you have a new, and then is international and get fees. So new is sort of like a constructor. So this is where a struct in Rust can look kind of like a class in languages like Java, but it isn't quite the same. So we have a struct. We are attaching to it functions that are like basically methods, and we will use those to add functionality to our package. The new is like a constructor. These are like methods in other languages. The fact that they take a reference to self as their first argument. Now this would be kind of like in Python, where class methods take self as their first argument. That's what's happening here. So these are methods that only apply to this struct, and you would call them by saying thing dot is international, thing dot get fees. And the thing dot is where the self comes from, and any other arguments actually go in the parens after the dot, after the call. So we can create a new package. This is why they did the I-32. They want to have this check here. So we'll hand it these two strings and a weight, and the first thing we're going to do is check that the weight is greater than 0. They actually don't allow 0 weight packages. And we're gonna Rust panic. I don't know that I've ever written a panic before. So it is panic bang for the macro. That I think is what I was used to seeing mostly. Where's an example? Panic. So panic bang, and then we can have a format string and pieces. Okay, fine. So we can do that. So we can say panic bang, the package weight must be positive. Boom, ba-dum, 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 weight in grams. Okay. So that ensures that the weight has to be positive. And I wonder if they have a test down here. No, they don't have. Oh, yes, they do. That's sort of an odd name, because it's not that it's weightless. It's just that it has a illegal weight. It's sort of not a great name, but they're saying that this code should panic. So when everything compiles, we ought to be able to get this done. Okay, so now we've got otherwise it'll create the package. Great. Now we need to do this. So is international presumably returns a Boolean? Let's look at the test. Yeah. So I'm guessing if the sender and recipient countries are different, then we'll consider it to be international. If they're the same, we'll consider it to be local. And yes, this returns a bool. So bool. And then we'll need to, so we need to say if now because we're in the, I think it's self dot sender country. Now I don't know how to compare two strings. I don't know. Oh, and actually we don't really need if, because we're just going to say this not equal to self dot destination, no, recipient country. Does that part compile? Does. Zippity-doo-dah. Okay. So it's international if these two things are different. Now, I don't know for sure that this works, and I want to look that up later. But, and then get fees, that's going to return, oh, so it's just, we have the weight in grams as an I32 and the cents per gram as an I32. So we can get the cents by just multiplying those together. And it looks like we just continue to do everything as I32. We're not getting into floats. That's what I was worried about, is whether floats came into this picture or not. But it doesn't look like it. One could argue that I really ought to make that result an I64, because if you multiply two I32s, they could exceed an I32, whereas if you multiply two I32s, they will stay within an I64. But I think that is definitely overthinking it, and I'm not going to worry about it now. So I'm going to return self dot weight in grams times cents per gram. Boom. Now, maybe, hey, it worked. All the tests passed. So let's actually back through here. If we don't panic here, will that even compile? Yeah, it expected a package here. Well, what if we returned the package? Hey, whatever. Yeah. What if we returned the package? Now so it compiles, but the test fails. So this test that should panic failed. So this annotation saying should panic, this is saying this function is a test function. This annotation is saying that function ought to panic. We're expecting it to throw an exception, as it were. But in this case, that in Rust means we're going to panic. And we didn't panic, and so the test fails. And so we get that the test did not panic as expected. So we want to, let's see, get rid of that comment, uncomment that, remove this. Boom. Now everything should pass again. Indeed it does. Let's get rid of that and that. Now, if I change this to double equals, what happens? Okay, it does fail. So where? So the assertion that failed was that this was expected to be false, and it wasn't. So it actually doesn't tell us for sure that this is doing the right thing. So I actually want to string rust string equality. Ways to compare strings in Rust. So we can use .ne and .eq. Now, what's the real question is what's different between the equality. Here, let's oh, so double equals and bang equals just call EQ and NE for us. So what we have is fine, but we could have also presumably done dot NE and that I think will pass. Because this is interesting. So we don't want to give away our recipient country and lose ownership of it. We need it to stay in self so that we can work with it later. And if we just passed it like this, we would be giving ownership to the NE call, and we don't want that. We want to make sure we keep it. So we're going to loan it to NE. Yeah, okay. That's interesting. And so the bang equals that I used before must have implicitly done all the loaning stuff for us. Okay. Well, that's interesting. Questions about that? Actually, and there's a good comment. If I want to worry about it, I use the checked mul operator on the number types. It returns an option. Oh, thank you. That's actually a good idea. I didn't know that. But that makes a lot of sense. So it would presumably notice if I was exceeding an I-32 and give me the opportunity to realize that I had gone past the capacity of an I-32 and do something useful about it. That's cool. Thank you. Here, well, I mean, obviously in this little bit of code it won't matter, but let's actually have a look at that. So let me put this back, make sure that that passes, and let's see what that would look like. So let's rust checked mul, get the syntax. So multiplies two numbers, checking for underflow or overflow. Yeah, so what does that look like? Well, here, this will presumably tell us checked mul. Yeah. So we can have a number dot checked mul some other number. Okay. That means we ought to be able to say, I'm going to comment this line out. That'd be able to say self dot weight in grams dot checked mul cents per gram, except that doesn't seem like so that didn't like that. Oh, I wonder if I need no. So why? So I'm going to get a sum or a none back. So I need, so I could, just for grins, unwrap, right? And that's not a great answer. But why is it saying that? Oh, because I've got a semicolon at the end. Ah, dadgummit. So again, like I mentioned last week, if you, and I'm going to make this mistake a lot. If you put a semicolon here, you return. If you don't have an explicit return, it returns the value of the last statement. Without the semicolon, this is the last statement. With a semicolon, there is an empty statement after that, and it returns the unit type, open paren, close paren. So that's why that was happening. So this now works. Without the unwrap, this will fail to compile because I'll have the wrong type. Yeah. So this is now an option, not an I32. If I unwrap it, I'm assuming it will be correct and it will panic otherwise, which is really all I would probably do if I were to check. So I feel so I think the syntax, this is getting me out beyond my sense of the world. So I think, actually, let's Rust match syntax or match example. So it is semicolon, curly brace, and then option, fat arrow thing. So I want, and I'm going to have some or none, right? Those are my options back here, some or none. So if I have none, panicking, the fee overflows with weight, and cost per period. So self dot weight in grams and cents per gram. So that is that. And then do I need, oops, back over here. Do I need some sort of syntax after the, I need a comma after the fat arrow expression. Some result, return result. Okay. And then I need, I think that's it. Fingers crossed. Test will pass. Hey! The test passed. So by default, debug releases panic on overflow and wraps in release. So I'm not sure I understand the implication here. So we're saying that the package struct derives debug. Are you just saying that we could have actually I'm not sure I understand. If you could say a little more about what that means here and what that would do, what implications that has for what we're doing here. Because I'm not sure I fully grok that. But that was kind of cool to add that check. Now I said here that it overflows. Technically, it would also underflow if we had the right negative. One of these was a large negative value, and we don't actually check that the cents per gram is positive. It wouldn't make sense to have negative values, but we don't check that. So, okay. I think I'm good there. Questions? Anything before we move on? Oh, here we go. Cargo run builds a debug build without optimization with debug info. Cargo run. Oh, yeah, okay. Yeah, right. So I get that. So the comment is that cargo run by default will build a debug version of the code. So it'll like do things like keep all the symbols in and line numbers, the kind of things you need for error messages to be useful. But the kinds of things that can also slow things down or increase the build size if you're trying to actually like build a production system. Cargo run minus release assumes you're doing a production build and pulls a lot of that stuff out so that debugging would be more complicated if the system crashed, but your system will probably have a smaller memory footprint, and it applies various compiler optimizations so that the code runs faster. So with in production mode, I assume the debug stuff is stripped out. And for example, all of the test code here is included in the non-production build. It'll be in the debug build, but it would get removed from the production build, so all of this test code wouldn't be there. So that's cool. Okay. I'm gonna, I think, move on to the next thing, if there aren't questions. Too much. And okay. We've moved on. We finished Structs. No, we haven't finished Structs. Hello? Oh yeah, we have. Duh. I need a nap, obviously. So Struct 3 is green, so it's done, and we've moved on to Enums 1. So let's tidy up shop here, close these guys, head over to Enums, and let's look at Enums 1. Okay, so Enums are actually super cool, and it's interesting. They're an old concept. They were widely used in languages like Pascal and its derivatives in the 70s, and some of the predecessors of languages like that in the 60s and 70s. C didn't really include them in a useful way, and they kind of disappeared. And you don't have them in Java, for example. But I think they're actually quite useful. They are an option in a lot of functional languages. Haskell and Erlang/Elixir both support kinds of enums. But Rust has very nice enums. I like Rust enums. It's one of the things that makes me happy about Rust. So here we're defining an enum message, which can have various options. So if we flip back over here, actually, I bet I can. Is it going to be in types? No. I wonder where that. Oh, primitives, possibly. No, custom types. Here we go. Enums. So we can have an enum, and it can have a set of options. And the options can just be basically a single label, but they can also be more complicated things like structures and tuples. So I think for the moment, we only need probably a list of options. And I think that will probably do the thing. Hey, look, it did. And notice here that printing these actually prints the label that we gave them. So that's kind of nifty, that it kind of knows how to print things. Now, we haven't seen curly brace colon question before. Normally, you would have just two curly braces, but not all things are printable in a useful way. Primitives like numbers and strings are, which is really all we've been dealing with for the most part. So we've been able to just have curly braces in our format strings, but there are other types that do not know how to print themselves in a simple way. But if they derive debug, so basically this is kind of like inheriting from debug, or yeah, I mean that's probably because it's not really like saying implement an interface because it brings the implementation with it. So it is a bit more like inheriting from this, but it knows how to do debuggy stuff is what we're saying. And enums, Rust enums know how to do debuggy stuff if we ask for that. So this is saying we're going to make an enum. Would you please add the debuggy bits for that enum for me? And part of that is the ability then to print the enum value in a useful way. If you're using the format string and you're printing things that are only provided by the debug trait, then you have to put the colon question in. So you're indicating I'm printing something that depends on debugging. And connecting to the comment earlier, this is important because in production code, the debug stuff won't be there. And so I don't think this would work. I think this only would work in a non-production environment. And so this is a syntactic reminder that we're using things that will only work in a debug environment. So, possibility. Yay, that worked. That was pretty straightforward. And the nifty thing with a enum, and I'm sure we'll see examples as we move forward, is that we can have variables that have these types, and we can do tests like, if we're in this case, do this kind of stuff that can be pretty nifty. Okay, so I'm going to say I'm done unless there are questions or comments. And now we're on to Enums 2. Okay, we're gonna have to define some different variants, and now we're implementing a function call on messages. So this will make this a little more complicated. So let's first just try to get the basic message stuff happening. So we have move, echo, change color, and quit. Now that's not going to work because if we look at this array of messages, move specifies an X and a Y. So it uses the struct syntax here to say if you're using the move part of the enum, you need to provide an X and a Y value. And we didn't do that here. So we have to say X is of type, I don't know, I'll say I32, and Y is of type I32. We don't have a lot of information to go on about what the preferred type there would be, but that I think will make the move error go away. It did. And now the echo, so whereas the move used the curly braces to indicate that we were using a structure, echo uses parentheses to indicate that we're using the tuple type, and that the tuple has a single element, which is a string. So we ought to be able to say echo s colon string. And now, hey, all kinds of stuff compiles. Oh, except, no. You don't provide in the tuple, you don't provide the name. You just provide the type. So, and it died so badly that it didn't even get to the other things. Okay, so I think that then gets us through. Oh no, change color also takes 3 values. These are probably RGB bytes, so we could probably say U8, U8, U8 there. So 3 unsigned 8-bit values. Oh, it worked. That's awesome. I guess I somehow assumed we were going to have to do something here, but there's not a to-do there. So, okay, so we make this array of messages using our syntax up here, and then we loop through them for message in reference to messages. So we're going to borrow this array long enough for the loop to go through and get the values out of it, and do something with each of them. And so this is very similar to the Python 4 syntax. And I think Kotlin provides a syntax like this, which is one of its advantages over Java. And then we're going to call on each of those messages, and call, so takes self, the thing that the message in this case that we're calling call on, and we're printing that enum using again the debug syntax. And so that debug syntax prints the entire enum, so in this case move with x and y being 30, echo with the string hello world, change color with 200, 255, 255, and then quit doesn't have any associated information. So pretty cool. I think that takes care of that, unless there are any questions, comments, rude remarks. Cool. Save. Moving on. And now we should have enums 3. So we got to implement variant types as we do below. So where do we see? Okay, here we go. So message, we have change color, echo, move, and quit again. And change color is a these have like constructors. Okay. So this is going to be more complicated. So change color, echo, move, quit. Let's start with that. Change color, echo, move, quit. Now that will fail a bunch of stuff. So change color requires that we have an argument, and it's a little weird here. This is actually putting a tuple as the argument, so I think we need this. So So I think that'll fix the change color problem. Yeah. So this is different. Over here, change color had 3 separate values that were each a U8. And so we passed it 3 arguments here. Now they are passing in a single argument, which is a tuple containing 3 values. So instead of passing 3 arguments, they're putting all 3 arguments in a box, a tuple in this case, and passing that tuple to change color. So we need to similarly have our change color take a single value, which is a tuple containing 3 values. Oh, okay. Echo is a tuple that takes a string, so that's the same as before. And move, okay, here this is different. Move takes a point. So they've defined a point as a struct containing an x and a y, which are both U8s. So we should be able to say that this takes a point, I think is the thing we want, because we want a single value which has the type point. Okay, so everything compiles, but one of our tests fails. Which test failed? Nice if there was like a line number. It's sort of weird that we don't get one. I would have thought that we would have gotten a line. Oh no, here we go. Line 63. So this right here is failing. And that's probably because we haven't done anything with state yet. So I feel like state probably, yeah, so we have to do this process thing. We haven't actually done anything with that. So they define state to be a color, a position, and a Boolean, which indicates whether you quit or not. And then we implement a bunch of methods on that state. So change color takes a state and a color and sets the color inside the state to be the color we passed in. Quit sets self-quit to true. Echo prints the string inside this. No. Oh, just prints a string that we pass in. Okay, that's kind of weird. Move position updates the position field with a new point. Process is what we now have to deal with. So process creates a match expression to process the different message variants. So each of these message variants, actually let me scroll to here, move this down some. Each of these change color, echo, move, quit, we're going to use these to call the right one of these. So if we pass in to process the change color, it will presumably call change color to update its internal color. And if we pass it quit, it'll call this quit method to update its quit state. So we need to implement that here in process. So we're going to have to say match message, and then again we'll have each of the cases, a fat arrow, and what to do. So change color, new color, fat arrow, change color, new color. Boom. Like that. And it's worth pointing out, if I try to save this, this will fail to compile because we haven't handled all the it's message : change color. Okay. Change color not found in this scope. Self.change color. There we go. now we get to the thing I meant to bring up after we get through all my other little problems. So Rust requires that you handle all the possible cases in an enum match. So if you have, as we do, 4 cases, change, color, echo, move, quit, you have to handle all of those here. And we have not done that. And so that will not compile until we deal with that problem. And there is, I think, a default, so you could add wildcards as a way of saying, and anything else does this. In our case, we're not going to do that because we have to provide like a concrete piece of functionality for all of the message types, but there could be circumstances where you want to just default to something. So message : echo stir. Oh no, that's a type. We'll call it just S. Self dot echo S. Yep. I don't know why I put that in there. Don't want a semicolon. Message : move, and that takes a point. Spell it, type it out. And we call self dot move position, and we pass it point, and then message. Oops, I did a semicolon again. Too many years of too many languages with semicolons. Quit. And now quit doesn't have any associated data, so it's just quit. Self.quit. Boom. And you can put a comma in things like this after the last one, and Rust will be like, that's fine, I don't really mind. So I think that might work. No, I think we got an error. Oh no, it worked. Woohoo! So that actually did all the right things. So we're implementing. They provided these methods: change color, quit, echo, and move position, as functionality that a state can do. So if we have a state, we can say s dot do this thing. And then that's what's happening here. State dot process this, process this, process this. So we've got a state, and we call dot process 4 times with one of each of the 4 kinds of messages. And then we assert things about the state afterwards. So the state started with color 000 or black, and it ended with the color 255 0255, which would be purple or violet, a fairly pale violet. And we started with the position being 00. We end with 1015 because we set that here, etc. And so we use this to call the right one of these by checking which kind of message we were sent and using its associated data as an argument then when we call the appropriate method. Here, these are visible, and we could have used them directly instead of going through process. We can, I think, make these private. I'm pretty sure. I'd have to look up the details, but I'm pretty sure we can make these private, which would force us to go through process. So if we wanted to have a system where the only way to modify the state was to send messages to process, we could do that. And that would be potentially useful if process wanted to do some error checking, or if for whatever reason we wanted to hide the implementation of the state changes from the user and have them go through just this one interface, then we could modify the names of these things, the way they are implemented. They could potentially pass their the calls off to something else to do for somebody else to take care of it, and we would be unaware of that. Whereas if we're dealing with these things directly, it's exposing more of the implementation details. I mean, that's beyond this deal, but it is a thing that could be useful. So, okay. So, questions, comments before we move on from this one. And I think this is the end of the Enums. Yes. Don't know where we're going. Methods are private by default, but privacy doesn't exist between items. Oh, gotcha. But okay. So there's no sense that these things. In the same module. So all of this code is in a module. I have never explicitly declared a module at the top, but a given file, if you don't do anything, all ends up being in the same module. And so because state and this code that's using it, but this is, I'm not 100% sure. So if it's file is a module. That was helpful. Thank you. If we had only... Could we only bring in... Because this is a new module, we're declaring a new module here. We're getting the things in the outer module. Child module has access to the parent items. And this module is in this file. So the file is the parent module. This is a child module. And so this is going to have access to these things. But if we moved to another file, a different module in another file, then the parent-child relationship wouldn't exist. And we would have to make the process function public if we wanted people to have access to it outside of the module, I think. Not really what we're worrying about at the moment, but I think that would be true. Okay, so, but thank you. Very good feedback. I appreciate that. Okay, I'm going to make this go away. And we'll move on to the next thing. We're in modules. That may totally force us to address some of these issues. Because modules are definitely something I don't know as much about as I perhaps should. And we will all learn something new now. Okay. So we have a module sausage factory and a function main. We have get secret recipe, and it returns the string ginger, and make sausage we call get secret recipe, and we print sausage. And we're failing because make sausage is a private function. So this module, so as was just suggested a couple of comments ago, methods are private by default. So both of these methods are private, so they're only visible inside the sausage factory module. Main is outside of the sausage factory module. It's not in the module, nor is it in a child module. It's in the parent module, actually. So it doesn't have privileged access. So when we try to call make sausage here, we don't get it. I'm going to actually do the hint, because I suspect that will give us a quick I'm not in the right directory. Oh, where is my directory? Actually, I don't honestly remember. Wah, wah, wah. PWD. Oops, PWD. Document streaming rustlings. There we go. Okay, everything is private in Rust by default, but the keyword we can use to make something public is probably like pub. Pretty sure I've seen that before. So let's try that. Pub. And indeed, we get a blue, which suggests that we've got an actual keyword. Yeah, quitting watch was not smart because now it had to redo everything. Hey, that's all we had to do. Okay, that's awesome. So everything, and this is one of the things I really like about Rust is I think Rust has made some really interesting decisions about what the defaults are. So the idea that a variable is by default immutable and that you have to say you want it to be mutable. I think that's very cool. That a function is by default private and you have to say you want it to be public. I think that's very cool. And so I like this. I think this is neat that you get encapsulation by default, you get immutability by default. You can have the alternatives, but you have to say you want them. You have to be explicit about that. I think that's actually pretty nice. Okay, so that actually takes care of that. So now we print, and I mean, they don't make it clear here, but this make sausage can call get secret recipe. So we could say something like this, and then we would get ginger sausage, right? Yeah, we get ginger sausage. So we can call a public method. It is allowed, which we knew before from here, but it didn't really do anything. It's allowed to call private methods and use those values or that logic in the process. And that's pretty cool. Okay, so I'm good with that. Boom, modules 2. So we got some question marks we got to deal with. You can bring modules into scopes and provide new names from the use and as keywords. Fix these use statements to make the code compile. So we have a module delicious snacks, which has two child modules, fruits and veggies. And fruits has a pear module and an a pear variable and an apple variable, and veggies has a cucumber and a carrot variable. And we are going to print delicious snacks fruit and delicious snacks veggies. And this outer module, parent doesn't have privileged access to child modules, although children have access to parent, which that's going to take some getting used to. In Java, for example, an outer class has access to the inner class and vice versa. I think there's full transparency both ways. And so I think I'm used to the parent class also having access to, or parent module I'm used to the parent class having access to the child class components. So I think I kind of map that to modules, and I'm going to tend to think in terms of parent modules having access to child modules, but that's not true. So the parent module needs to say it wants access to pear and cucumber in some fashion. We could just say use it, and then we would get pear or cucumber. And I think actually if I were to comment out the as part, this might work. It's not the solution. No. Oh, I probably need a semicolon or something. Yeah. Yeah, I need a semicolon here. Wah, wah, wah. Okay, so it, here we go. Fruit not found. Oh. Ah. So this is what's going on. So we're trying to print delicious snacks, lowercase fruit singular, and veggie singular. And we can't be printing modules anyway. I'm not sure that modules would have a meaningful print. So what they're asking us to do is to have pear be fruit and cucumber be veggie. So we need to sort of have a name fruit here, and we need to have a name veggie here, and that's where these are coming from. So we're, whoa. Private constant import. Or not. So I'll come to the pub crate thing in a second. So I have to think for a second. I think actually I'm going to use the hint. Phone a friend. Wah, wah, wah. So the Delicious Snacks module is trying to present an external interface that is different than its internal structure, the fruits and veggies modules and associated context. Complete the use statements to fit the uses in main and find the one keyword missing for both constants. Aha! So I bet I need the public. No, because these are public. As pub fruit? Ooh, well that didn't like blow up. See if that does a thing. No. Did not like pub fruit there. Pew, pew. Okay. So I need a private constant import. Constant import fruit is private. So how do I make it not private? Well, let's ask the internet. Rust, Bill. Oh, I love that. So we have somebody has asked exactly this question. And I love how they're like, I have the following code, but I'm not going to tell you where it comes from. And so somebody will presumably pub use. Oh, so the pub, I had the right idea, but the pub goes at the front, not over here. Okay. So pub and pub. Is that going to work? Yeah. Okay. So by default, use sell fruits pear as fruit. The name fruit would be a reference to pear, but it would be a private reference within the module Delicious Snacks. And so my attempt to use it here will fail. And if I put a pub in front of it, just like these pubs here, then I will get this name will be a name for this thing, and it will be publicly visible so I can refer to it down here. So that name is publicly visible down here. So we get favorite snacks are pear and cucumber. And presumably I could change this to apple, and I would get favorite snacks are apple and cucumber. Notice I could not say carrot here because carrot is not in the fruits package. So we get no carrot in delicious snacks fruits. So it looks in fruits for something called carrot, fails to find it, and that does not work. So we have to stick to things that are in the right module. Now we're declaring pair here to be a string with a string slice with the value pair. Now we've never seen the tick static thing before. This is lifetimes, which I presume must show up somewhere, although I don't see them, so I'm not sure where that's going to happen. But because of the way Rust handles borrowing and dropping, freeing up memory, sometimes you have to say how long a value can live, because Rust can't figure it out and doesn't know when it can legally drop something, free up that memory. And a tick followed by some sort of identifier is a way of saying this has a named lifetime, and you can say various things share a lifetime in some way, which doesn't make a lot of sense right now, which is why I'm assuming there'll be some discussion of this later. But static is a special lifetime, which is the entire life of the program. So this ensures that these strings will exist for the entire life of the program and not be dropped at any other point. And I think that's necessary because without it, I'm not sure that this would persist past the declaration of the module. In fact, if we remove it from one of them, I assume something will fail. Oh, no, it did not fail. But I wonder if that's by accident and not by design. I'm not sure. Well, I'm not going to, static is complicated. Let's not go down that road right now. So in the comments, Patatas del Papa pointed out that there is a visibility modifier called pub crate, which will make the item public through your whole crate, but an external crate will see it as private. So a crate could be, for example, a library that you package up and distribute as a sort of a bundle, a library, and that could just be internally, but you could also post it on something like crates.io, and then other people can declare dependencies on that crate, and Cargo will pull those in when you build your project. And so if it's pub crate, it's visible in your crate, in your library code, but then it'll be private to anybody who's using your crate, and that would be kind of nifty. And apparently there's pub super, which imitates the Java behavior and makes the contents of a child visible to the parent, which, actually I kind of like the idea that by default, again, I think the defaults are good in Rust based on my limited experience. I've never built anything substantial, although I do have plans to build quite a few things in Rust over the course of sabbatical. So if you're interested, we'll get to do more Rust programming down the road. But based on my limited experience, I like the fact that it defaults to what it defaults to. So I think that's quite cool. Okay. Other comments, questions? Gonna save that, move on to modules 3, where I will no doubt be more confused. Well, so you can't use the use keyword to bring module paths from modules from anywhere, and especially, you can use, I think I said can't. So you can use the use keyword to bring stuff from any place, including the Rust standard library, into your scope. So they're suggesting bring system time and Unix epoch in from standard time modules. Bonus style points if you can do it with one line. And so let's do it. Let's not worry about the one line first. Let's just get it to work. Time, system time, and use standard time Unix epoch. So that I think will work. Yes. So we have, I think, a parent module with a child module time that defines a component system time. That's probably a struct. And parent modules std, submodule, child module time, and component Unix epoch. And so that gives us system time, which has a method now, which gives us the current time as some kind of time object, a system time object, in fact. And a system time object has a method duration since, which takes another system time object and does the rather complicated time math between those two things, which is dead useful. Like, you really like things like this because time and date math are so awful that any good library that does that for you, totally awesome. So we're asking, how long has it been since the Unix epoch, which, if you're not familiar, is midnight, January 1st, 1970. So that's actually what this is saying here. So for reasons more historical than sensible, Unix decided to start the clock, as it were, at midnight, January 1st, 1970, which says things about when Unix was being developed, among other things. And it counts, the standard notion of time in Unix is the number of seconds since that moment. And there is a Y2K-esque issue coming up where that value, that number of seconds since 1970, is going to overflow, I think, 32-bit integers, if I remember correctly. And that there's a fair bit of code floating around that has times being stored in 32-bit values. And those are all going to roll back over to 0. Or if there's, actually I'm not sure if we're talking signed or unsigned, but probably unsigned. So then they would roll back over to 0, and that would be problematic. And so people are working on that. It's less sexy than the Y2K thing because it's harder to explain. And I think people feel like, in general, this is being addressed, but I'm not in this space well enough to say anything more sensible than that. And duration since returns a result type. And in results, in Rust, Result types are a way of saying this might fail. And so you have an OK, so it's an enum, and you have an OK option and an error option. So the OK option holds an n, which is the value, and so then it prints n as seconds. And that's what we got down here, is that 1970 was a very large number of seconds ago. And that if for some reason duration since failed, and it could fail if earlier is later than self, for example. That's interesting. So if it fails, in this case, we're just going to panic and say that the system time is before 1970. And that would be obviously a problem. If we were to set our system clock to like 1965, we could presumably force this to occur. I am not going to do that now. Okay, so this works, but bonus points if you can do it with one line. I feel like I've seen this, but I don't remember what that looks like. I feel like it's maybe curly braces with the names in. Oh, we could use glob. I was thinking we could use nested paths or the glob operator. So glob's a little hardcore. So let's try glob first. This is not my preference, but that should work. So that brings in everything from STD time. And we really just wanted those two things. So that works, and it is one line, but I don't think it's the best option. I think we can say that we want just those two. And what did it say? It said nested paths. Rust nested paths. Nested paths. There we go. It is curly brace. Okay. So we can have curly brace and things. Okay. Separated by commas. So I think we can just say curly brace, system time, comma, Unix epoch, close curly brace. Get rid of that. Boom. And yay! Oh, that's much shinier. So star worked. The glob worked, but it gave us everything. And so it was not a very precise use of use. We were just grabbing the whole shelf of stuff when we really just needed two things. And this allows us to say we want these two things specifically. So that's pretty cool. Okay. Nifty, nifty. I'm going to say I'm done with that unless somebody's got a question. Going. Pew. Okay. Now, where do we move off to? We are done with modules and we're into vectors. Okay. Close all those. Close modules. Vectors. What? Oh, collections. We're in collections. And we're in Vec1. Okay. So we'll talk about vectors here and hash maps. And vectors are similar to sort of like an array list in Java, or not unlike an array object in Python. So we can add to vectors if they're mutable. We can push onto them and they'll automatically resize as necessary. Yeah. Okay, so our task here is to create a vec which holds the same elements as the array A. And we need, there is a vec bang that would give us an empty vector, and then presumably some test will fail. Yeah, so that compiles, but we wanted, down here in this test, we wanted A and V to be the same, and A was 10, 20, 30, 40, and V is just the empty array. So that didn't work. It moved us in a direction. And that's what they mean here, I think, by the vector for macros. But I'm not sure what the syntax looks like for grabbing a bunch of stuff from an array. Okay, one way is to use vec_new to create a new vector and fill it with a push method. That's what we don't want to do. Second way is simpler, is to use the vec_bang macro and define your elements inside the square bracket. Oh, are they really just asking us? Oh, I bet they are. I bet they're just suggesting to do this, which is pretty brutish, actually. I'm not super jazzed about that. Oh, apparently I have a 404 link in my title. That's bad. I will have to try to fix that. Thank you. And Patatas del Papa says character limits. Oh, the title problem is because of a character limit issue, I bet. Okay, well, poop. I will, well, oh yeah, that looks like that might be the problem. I'll deal with that later. But thank you. If you're curious for whatever reason, all that linked to is that puppy right there. So that's the URL for the Rustlings exercises. So yeah, I think you're completely right that it's a character limit. It seems to have chopped that off. I'll fix that afterwards. But thank you for pointing that out. Appreciate it. So that passes. I feel like there's something less gross that we could do here. That we can make a vector out of an array. Rust make vector out of array. Convert a slice or an array to a vec. That's what we want. To vec. Let's try that. Let v equals a dot to vec. Yeah, so that's prettier. I like that a lot better. I don't know that that's what they intended, but I certainly find that to be less icky, because just repeating the numbers makes me want to cry. So cool. So we've made, this is an array, so that's a fixed length thing in memory. In this case, I think it's on the stack. And it's got the 4 values, and we can't do anything about that. We convert that to a vector here, which is this vec i32. So this is saying that this is going to return a vector of 4 values. So length 4, an array of length 4 of i32s. This is saying we're going to return a vector of i32s. Vectors don't have a fixed length. They can be whatever length they need to be. And so we convert the array to a vector here. We return the pair. And then in the test, we get those two things, and we assert that they are equal. Okay. Questions about that? Boom. And we're on to vec2, not surprising. So a vec of even numbers is given. Your task is to complete the loop so that each number in the vec is multiplied by 2. So we've got vec loop takes a mutable vector of I32s. And so that's important because we'll be updating the vector. And if we were not passed a mutable vector, we wouldn't be able to do that. And we're going to return a vector of I32s. And so we're going to iterate over the items in the vector. Now, iter mute, this is a little weird. Iter mute gives you something, and if you change the something, you are changing the value in the vector. So in a lot of circumstances in other languages, if you had a for I in some array, vector, whatever, and you modified I, it would have no effect on the container, especially if it was a primitive. If it was like an array of stacks and then you push something on each of the stacks, then that would side effect because the array of stacks is really an array of pointers or references to stacks. But if you had an array of ints and you iterated over those and modified the ints, you probably would have no effect on the collection. Whereas this iter mute in Rust means that every one of these is actually the thing in the collection. And if we modify the thing in the collection, we modify the collection. And that the mute here is necessary because iter mute is only available on mutable things, which we can see with this and mute here. We need a mutable reference. So if the vector was not mutable, we wouldn't be able to do that here. So I think we can just say I times equals 2. And fingers crossed. No. So can't make this a little bigger. Can't use star equals. So I is actually, if we hover over I, come on. Oh, it doesn't tell us something useful there. But I is a mutable reference to an I32. It's not an I32 directly. So it's it's a reference to one, which you think about it makes sense because we want to have a reference into the array to say this value that I'm pointing at so that I can go through that reference to change the actual value in the array. And so this would say take the value pointed to by I, the value being referred to by I, and multiply that by 2. So if we think of I as being a pointer into this array, actually we'll do it this way, pointer into this array, so it starts here pointing at this value, and then in the for loop it moves on to the next one and it's pointing at this value, and star I says go to the value here, not the pointer to the value, and then that value multiply it by 2. And this is a place where, again, the Rust compiler error messages can sometimes be super helpful. So here it basically told us exactly what to do and why to do it. And I haven't talked about this, but this error E0368, that's actually a specific error number. And if you Google that, like Rust E0368, you'll get a web page that talks about that error and has examples and ways to potentially deal with it. Some are more helpful than others, but many of them are actually quite useful. And so if you're like stuck somewhere, Googling the errors can sometimes be super helpful. So I think that now if we save, we may have solved the problem. Hey, look at that. That's pretty nifty. So, yeah, so we dereferenced I to get the value it was pointing at, and then we said take that derest value and multiply it by 2. And syntactically, I must say, I find the ampersands and the stars and stuff can get a little overwhelming in Rust, and I find it kind of nuts. And I wonder, I don't think this would be very rusty. Okay, you could do that. So if you wanted it to be clearer that the star here was applying to this I, and that was then an expression, so we were getting the thing pointed to by I, and then that expression is being multiplied by 2, that would be a thing. And I think, so we'll take it back because I don't think that it's what people normally do. I'm curious, I think we could do star I equals star I times 2. So if we didn't want to use the star equals syntax, that would work. But that's just an awful lot of stars. Oh my gosh. That really just makes my head hurt a whole lot. So I definitely don't think we want to do that. Yeah. Okay. So questions, comments? Okay. Gonna get rid of that. And then we're on to HashMap 1. Okay, a basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits, apple, banana, mango, in the basket, and a total count of all fruits should be at least 5. Okay. So, let us remind me what the HashMap types? No. Where are collections? I thought I'd seen them. Well, that's annoying. I'm sure they're in here somewhere. Or if they're in standard library. Oh yeah, there we go. HashMap. Okay. So HashMap, what does that look like? So we can declare it new and insert things. I feel like there's a syntax for just making one. Maybe not. Maybe the easiest thing to do is just to insert. Okay, well, we'll do that. So, and it was HashMap new. HashMap new. Oh, and yeah, if I looked ahead, I would have seen that that was what they were doing. Okay. So we make a new empty hash map, and a hash map here is like a map, a hash map in Java, or a dictionary if you're a Python person. And so yeah, it's a container for key value pairs. We can add things to it. It has to be mutable if we're going to change it, which in this case we are, because insert requires a mutable reference to self, because we're changing the hash map. So basket.insert string from banana to 2. So we're going to have a key, which is the string banana, and we have 2 bananas. And so they want us to put some more fruit in. They said bananas and mangoes. Let's go with that because I don't want to have to be creative. Basket.insert string from apple, and I don't know, we'll have 7 apples. And basket.insert string from kumquat, and we'll have 87 kumquats because why not? Boom. And then they return basket. So fruit basket's returning a hash map of strings to U32s. So we've got banana 2, apple 7, kumquat 87. And the tests check that there are at least 3 types of fruit. So we make a basket. We assert that the length of the basket is at least 3. So the length will be the number of key value pairs in the basket. We want to make sure we've got at least 5 fruits. So we get a fruit basket. Basket.values gives us a collection of all the values in the basket, which in our case is going to be 2, 7, and 87. And then .sum is a built-in function on collections of numeric types that will add them all up. So we'll add up our 2, 7, and 87, and we should get 96, I think. And 96 is at least 5, so this should pass. So let's save that and see if that works. Wah, 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 yay, it does. And if we did something rude, like change that to a minus 87, that would fail. Oh, they're U32s, I can't do that. Let's say there's just 1 and there's only 1 kumquat, so that there's 4 total. And so yes, we fail because the sum was not at least 5. It was less than that. So we could put that back. Oops. And if we were to comment out this one, we'd pass the at least 5, but we'll fail the 3. There's need to be at least 3 different fruits, so basket.len being at least 3 fails because there's only 2 things there. And we could add another one, and that would be totally fine. String from tangerine 12. And that should be totally good. So we can have more than 3 fruits. We can certainly have more than 5 total items. Oh yeah, so there's a comment preferring to string rather than from. So there are different ways to turn string slices into capital S string objects. From is one, to string is another. Apparently, in the early days of Rust, there was a performance difference, and you can still see people arguing about that. But apparently now there's not, that toString turns into from, or the other way around. Sort of if you dig through the code, they turn out to be the same thing. I think there's one extra function call for one of them than the other, but the compiler is likely to optimize that function call away in a production setting, and so you would never actually notice. Now, I don't know the avoiding accidental URLs. So presumably the from Oh no, I think he was just doing some typing to avoid the system thinking that he had a URL. So that's why he put spaces there. Okay. So I don't think it matters a lot. But we could, to see it work in action, we could say apple dot toString, and I think everything will still work fine. Yeah. So this converts a string slice into a capital S string, and so Patatas del Papa, do you have a reason you prefer one to the other? It seems like this, from what I've seen online about this seems to be like one of these odd bar fight moments where people often care, but it's not obvious why they care. And I'd be curious to know if you have, some particular reason or not. But cool to know. It's good to know that there are the two options, so I appreciate that. Okay. Other questions or comments before we move on to the last hash map, which might just be the last thing we do today, because we are approaching 12. Okay. Boom, boom, boom. So hash map 2. A basket of fruits in the form of a hash map is given. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. So basically the same as the previous setup. You have to put more than 11 fruits in the basket. 3 types of fruit, apple, mango, and lychee, are already given in the basket. You are not allowed to insert any more of these fruits. Okay, so apple, mango, and lychee. Apple, mango, and lychee. So we have banana and pineapple are available. The basket, okay, so we're making a vector of the fruit kinds. For fruit in fruit kinds, put new fruits in if not already present. Okay, so we're going to have to actually check to see if our basket already has a given fruit. And if it doesn't, then we'll put some of that type in. And if it does, we'll leave things alone. So we're going to have to say if basket dot get fruit. Now what does that return? Yeah. Okay. So it returns an option because there might not be that fruit. So Patatas del Papa says muscle memory and likes the look of it better for the toString versus from. And I actually kind of like the from, visually, to be honest with you. But I haven't thought about it very hard, and you have more experience than I do. So, so if basket get fruit, so basket get fruit is going to return an option type because there might be something there or there might not. So we really don't want an if. We want a match. And we want to say that if nothing is there, we do something. And if some fruit is there, then we do something. In fact, we don't want to do anything if there's some. I'll figure out what that looks like in a second. But if there's not already something there, then we want to say basket.insert fruit. I don't know. Let's put in 7. Boom. And now if we don't want to do anything here, I'm not sure what the right syntax for that looks like. Let us go ask the internet. Rust, do nothing for match case. I was wondering if unit was the thing to do. Okay, I can deal with that. So we'll just say unit, and that should, for each fruit, see if we've got that in there already. If we don't, then we'll insert an entry for that fruit and say 7 things. And if there is something there, then we'll do nothing. Fingers crossed that will work. No, did a bad. Right. No. Why is this? Oh. Because this is an option. Types don't match up. So this has to have the same type as that. How did they get away with that in the example we were just looking at? Oh, because print line doesn't return anything. And I like unwrapping here isn't going to help because we'll still just have a different type mismatch. Yeah, unwrap's going to give us the U32, and I could just put a U32 here, but that doesn't seem like a good idea. That probably works, but I don't like it. Nope. Oh, got a different error. Oh, yeah, I didn't like it. Didn't like that. No. Oh, so there is a suggestion to use returns. That could work. And then I don't have this weird unit type because that does seem a little odd. So we could do this and return, and here we could just return. Oh, but no, return's not going to work because that's inside my loop. And I don't want to return from the fruit basket function. I don't think this is going to work at all. We'll give it a shot, but I don't think that's going to do the right thing. I think we still have a borrowing problem. Yeah, so I need to put an ampersand fruit here, and I bet I'm going to need an ampersand fruit here. Oh, actually I'm wrong. I don't need an ampersand there. Yeah, so my test failed because I don't have, so 4, 2 is 6, 11. Well, actually I would have thought this would have failed. or passed. Okay, so let's look at the tests. So we insert the fruit basket, get the fruit basket, and we check that those are the same. We check that there are at least 5 types of fruit, and this fails. So count fruit kinds greater than or equal to 5. This did not work. And I think that's because we returned too early. This forces us to return, and that's gonna be bad. And the suggestion now is that we just don't need the returns, but that curly braces will work. Oh, well, we certainly changed things. So maybe if we put a semicolon here, it will know that that's going to be the unit type. Ho ho! Good job. Thank you. Okay, that's interesting. And I don't know, given that we only have one line here, I probably don't really need this to be on a line of its own. So if there's no fruit of that type, then we're going to have to insert some number of those. And if there already was that fruit, we will do nothing. And the open close curly brace is basically saying do nothing. And the semicolon here gives us the unit type because we're returning the value of this empty expression, which is the unit type here, which matches the type here. And so the type checker can determine what the value of this match expression is. And everything's going to be copacetic. Okay. Interesting. Now, and I think if we had put zeros in here, the test would fail because we still wouldn't have more than 11. Yeah, the count would not have been greater than 11, so that doesn't work. We need to put at least one of the fruit in. Yes. Okay. Now, I actually want to say a little bit about the ampersands here. So, get takes a reference to the key type, whereas insert takes the actual key value. Now why? So I think, and folks that know more about it than I do. Okay, so there's a suggestion to use a let. I'll come back to that actually, because that could be useful. But folks that know more than me can sort of clarify that I'm getting this right. Get doesn't need to hold on to the key that we're passing in this case, a string. It needs to use it to look something up, but when it's done, and it can hand it back. So it will borrow this, hence the ampersand saying we'll take a reference to it, we're going to borrow it, but you get it back when I'm done. Insert needs to take it and keep it because it is using that as the key in the hash map. So it's adding that to the hash map. The hash map will then own that value and we can't have it back because it's now the hash map's value and the hash map's going to keep it. And so we need to give it this fruit here so we don't have the ampersand to make sure that the hash map can have it, use it as a key for all time, and it isn't our problem anymore. But if we tried to do something with fruit after this line happened, we would presumably run into trouble because we don't own fruit anymore. So yeah, I think that that's what's happening there with the 2 ampersands. Now let me look at the comments. So Patatas del Papa suggests using an if let. And then, or using an if, a normal if, with the is none method from option. So I think, let me see if I understand the suggestion. I'm going to keep my old code there for now. So I would say if basket dot get fruit dot is none. So I'm saying let's get the value. None is an option because get returns a capital O option, where none is then one of the possibilities. We can ask, was it none? And if it was, then we do basket dot insert fruit 1, and then we skip all that pattern matching. Ha ha, yes. That's very nice. Okay. I think I'm glad I did it both ways, because I think I'm not used to the whole option result stuff in Rust. That's not something that I've read. I've seen other people use it and read stuff about it, but it's not in my hands. I mean, as you mentioned earlier, Patatas, muscle memory, right? And this is not part of my muscle memory yet. So having the experience of seeing kind of how it worked both ways, I think was very nice. But I do think if I was writing production code, the second is clearly simpler. I don't have to think nearly so much. All that business with the unit type and the curly braces, all that goes away, which is very nice. And we eliminate what's really kind of a spurious case here by just sort of saying, hey, did we get nothing? If we did, then we have a thing to do, and we don't have to explicitly say, and otherwise don't do anything. We just leave the else out, which seems like a pretty nifty deal. Well, I think that's pretty awesome. I think it's 12:04. I think you folks are great, and I really appreciate the feedback and the hints. I'm gonna call that one done. We would move on to strings. So I'm gonna save that, and we'll come back Tuesday morning for more fun and excitement. I don't know, so actually just talking a little bit about moving forward, I don't know. By default, Tuesday we'll just continue doing this. However, if I feel like I really need to be doing some things relevant to the Minnebar talk, I might actually be doing some Neo4j JavaScript stuff instead Tuesday morning. And I may not know the answer to that question until Tuesday morning. We'll see. I'll try to post something on Twitter about that a little in advance. Maybe try to make a decision Monday about that. And I will not be here a week from today because I will be in Minneapolis giving this talk at Minnebar. So next Saturday's live stream is not going to be happening because of that. but I will be here Tuesday. I might also sneak in another one somewhere, depending on, especially if we do Rust on Tuesday, but then it turns out I do want to do some Neo4j JavaScript stuff. I might do that as a live stream at just some random moment when I have some free time and it occurs to me. And I'll try to say something on Twitter about that if it happens. Yeah. Thanks a ton for all the feedback. I really appreciate it. It was awesome. And I look forward to seeing everybody again later. I hope you have a great weekend, and I will talk to you later. Ciao.